Today we're going to talk about getting started with AWS CodeDeploy. My name is Andy Troutman, manager for the AWS CodeDeploy team. And we'll just go ahead and get started, jump right in. As a little bit of background, sort of a motivation for this talk, I want to kind of remind everybody that software deployment is still a hard problem. If you're in this webinar, you probably are already motivated by some of the challenges of getting your code updated on your production fleets in a reliable and safe manner. But I'll kind of talk a little bit about that life cycle. So, when most teams start, the complexity of doing a software deployment is very low. You're potentially a single individual developer on your laptop or on a dev box. Failure is not very costly, since failure basically means that you have to try again. Customers aren't impacted. But over time, automation is very unlikely at this point. Of course, the earlier you automate, the more reliable your automation will be when you finally go live with your application. And then the second stage is you actually go live. Now, instead of an individual working on an application, you probably have a team. There's coordination effort that is involved now, so multiple people might want to be updating the server at the same time. The number of instances or boxes that you need to update is growing, and so manual processes that you could just do by hand locally are going to start to not scale. They're going to be inconsistent. You might be launched now and you actually have customers that are using your application, and suddenly the cost of failure begins to rise because you don't want to disappoint your customers with a bad software change that they notice. And then if you make it all the way to this point where you're catastrophically successful, you've got lots and lots of servers, hundreds or thousands. If you haven't thought about how you're going to automate now, you're going to be in a lot of trouble, right? So the cost of failure is extremely high, lots of visibility. The complexity is extremely high. You may have a very large number of people trying to update the application, lots of servers, lots of coordination that needs to happen. And so this is really the background or the backdrop for AWS CodeDeploy and why we decided to put together a service to help AWS customers. So what is CodeDeploy? CodeDeploy is application deployments for EC2, as well as other stuff. So the other stuff, in our case, is last month we released a feature that would allow us to use CodeDeploy not only for Amazon EC2 instances, but also for on-premises servers. So you can use CodeDeploy in a mixed mode. You can use it to deploy to your local data centers or your laptops, as well as to EC2. So both of them are kind of possible with CodeDeploy. Kind of more specifically, what is CodeDeploy? CodeDeploy is intended to be a building block service. And what we mean by that is that CodeDeploy is really focused on solving kind of one specific problem that we heard customers having challenges with in a very crisp and succinct way. So CodeDeploy is really about doing fleet orchestration, coordinating a software update to one or many instances in a way that's flexible, so it works well with your existing process. It's reliable, so it's always available. It scales to kind of any size, so if you're deploying to one instance or 1,000 instances, CodeDeploy should work for you. And of course, it's safe for your end customers, right? So one of the things we really wanted to emphasize with CodeDeploy is that you should be able to update your software kind of fearlessly and know that the system will protect your end users in case you make a bad change or accidentally push something that you didn't intend to. We also call it a building block service because it's meant to slot into an existing process. We know a lot of customers probably have a lot of process already built up around the way they build software, test software, and release it. And so we want CodeDeploy to be something that integrates well into your existing process and kind of can grow with you as you move forward. So without further ado, let's just go through at a high level what a CodeDeploy deployment actually looks like. So in this case, we have three players: the AWS CodeDeploy service, Amazon EC2, and Amazon S3. So for the purpose of this application, we'll need a fleet to deploy to. So let's provision some instances. So here we have, we'll assume that we're going to deploy to 6 EC2 instances. We'll store our application in S3, so the code and configuration and all the commands that we'll use to do a software deployment we'll keep in Amazon S3. So the first thing that happens, or the next thing we need is a software agent. So CodeDeploy works using an agent that you install either on your on-premises instances or on Amazon EC2. This agent is essentially always connected to CodeDeploy. So the agent makes an outbound connection over HTTPS port 443 to the CodeDeploy service, and it's kind of holding the connection open, asking CodeDeploy if there's any work for it to do. Of course, when there's no work, it's basically just holding an idle connection. But the interesting part is when you actually tell it to do a software change. So let's assume we're going to deploy to all 6 of these instances. The first thing that the CodeDeploy central service is going to do is it's going to select some number of instances to deploy to in a batch. That number is controlled by you as the deployer. So we'll talk a little bit later about deployment config, but essentially it controls how aggressively you want the software change to roll out across all of your instances. If you're very bold, maybe you would do everything all at once, but chances are that for production, that's not really what you want. You want something that would do a more incremental deployment. So in this case, let's assume one instance gets updated. The first thing that's going to happen is the CodeDeploy service is going to send down a set of commands for the instance to run. Those commands, again, are specified by the customer using a piece of configuration we call an application specification, or more commonly called an app spec file. This file is going to have kind of 2 sections in it. One of the sections is going to instruct the CodeDeploy agent as to where you're storing your application. So in this case, it'll pull your application from your S3 bucket. The S3 bucket you supply is something you own. It's not managed by CodeDeploy, so you have kind of full control over what gets stored there, the permissions it has, kind of end-to-end on that. Because this is a connection between your S3 bucket and your EC2 instances, CodeDeploy doesn't have to be involved. We don't have to know anything about the application that we're touching. We can also deploy code from GitHub. So GitHub is another repository option. So if you store your code in GitHub and you want to use CodeDeploy to put it on your EC2 instance, that's also possible. So we pull the new version of your application to the instance, and then we run through a set of commands that you specify. So that app spec file that I mentioned just a little bit ago is essentially a list of commands that will run on your behalf, and they're organized, into what we call lifecycle events. So these lifecycle events are kind of specific plugin points where a customer would kind of naturally want to take an action. So before we copy the new artifacts onto the box, we can run scripts from your previous deployments, bundles. After the application is on the box, we can run additional scripts. After the install, and then at the very end, we would have a validation step, which you could use to kind of verify that the deployment to that instance was successful. Success for CodeDeploy is really, can we run through all of the scripts that you provide us without any failures? So when CodeDeploy is deploying to an instance, it's monitoring the outcome of each of these scripts that we're running. We want to see it finish, and we also want to see it return a 0 exit code. If it returns an error code or the script basically hangs indefinitely, you can set timeouts, and we also have sort of default timeouts to say, well, this script isn't completing, or the script failed in some way. As soon as a script fails, CodeDeploy is going to mark that instance as not successfully receiving the deployment, and then the centralized service will decide what to do thereafter. So again, depending on how aggressively you've chosen to deploy, we may continue the deployment and try it on a few other instances, or we may choose to stop the deployment completely and let the customer kind of step in and decide what they want to do for remediation. That could be to roll back to a previous version. So CodeDeploy will also keep track of previous versions that you've deployed and let you move between them. Or you may choose to patch something real quickly and redeploy. In this example, let's assume the happy case, which is the deployment succeeds. So we run through these scripts, everything works as expected. It will return back to the CodeDeploy Central service that it succeeded. The CodeDeploy Central service will then pick another instance. So this one succeeded, so let's move on. After that one, it'll pick another, and another, and another, and another. And of course, the end results that we want to see is that all of our instances run through their lifecycle events, and we get a successful deployment to the whole fleet. So that's kind of a really quick view of how CodeDeploy works at a very high level. Let's do it live. So I promised in the abstract that I would do some of these demos live. So let's see how this happens in real time. So this is the CodeDeploy console, what you're seeing now on your screens. This is kind of the landing page where we list the set of applications that you have. And I'll talk a little bit later about what an application is. But at a very high level, it's a piece of software that you want to put on your EC2 instances or your on-premise servers. So for this example, I'm going to do a deployment to what we call a rollout demo. So I click on rollout demo. Now we're looking at the details just of the rollout demo application. So on the left-hand side, we have what we call deployment groups. That's the collection of instances we're going to deploy to. And on the right-hand side, we have revisions. So versions of our application that are available to be deployed. So these, in this case, they're stored in S3. You can see the revision location is just an S3 URL. One other thing to know on this page, you can see this is an 18 instance fleet. So we've got 18 servers that are running that we're going to update using this deployment. So I'll go ahead and click on the version 2 of this revision, click deploy this revision, and then I will really quickly fill out some information. This is, I guess I should explain. So this is the name of the application, of course. This is the fleet that we're going to deploy it to. Our application is stored in S3. The rest of it's automatically filled out for me because I picked a specific version. And then down here at the very bottom, you'll see deployment config. Deployment config is what we were talking about earlier. It's how aggressive this deployment is actually going to be when we do it. So we have a couple out-of-the-box deployment configs for customers, one at a time, half at a time, all at once. I've actually created my own custom deployment config, which you'll see here is third at a time. So third at a time is just what it sounds like. The deployment is going to attempt to deploy to all of the hosts in batches of 1/3 of the total hosts. So in this case, we've got 18 hosts, so 6 at a time. While I do this deployment, I'm actually going to bring up this other visualization. So what I have here is a view of each of the instances that is going to participate in this deployment. So all of them are on version 1 now. You'll also notice that they all have an availability zone listed. The availability zone, so this application, we basically have divided our 18 hosts across 3 AZs in the US West 2 region. We always encourage customers, if they can, to distribute their applications across availability zones. This gives you the best reliability and availability. During any kind of networking event, you can hopefully kind of shield yourself from like a total outage by distributing, which is what we've done here. So let's kick off the deployment. So I'll click deploy now. It's going to take us to the deployment page, and it's going to show us that the deployment is in progress. Let me switch back to this view of the deployment, and if all goes well, we should see instances kind of update in real time. So there you go. So you saw that's the first batch of 6 updated pretty quickly. You'll also notice that it updated across availability zones. That's part of the CodeDeploy's fleet selection logic. If you give us hosts across many AZs, we'll try and logically distribute the deployment across them. This is so that if we did a deployment to all one AZ and that AZ should experience a failure, you wouldn't be kind of out of luck. You wouldn't, we kind of want to kind of distribute your eggs across many baskets, so to speak. So that happened pretty quickly. You can see the deployments already green for our instances. If I go back to the page, you can see our little status bar down here. So you can see 12 instances succeeded and 6 in progress. The application updates immediately, so those go green as soon as it's standing up. But we do have some verification that we do afterwards, which is why you'll see that the deployment is still ongoing, even though the instances see themselves as complete. So now you see 18 instances succeeded. I'll come back to this page, but I just wanted to kind of connect the dots between the PowerPoint and what you would actually see using CodeDeploy the service. So let me head back to the slide deck. Let's talk about some of the nomenclature or the concepts that that you saw when we were working with the CodeDeploy application, or sorry, the CodeDeploy console. So at the top level is an application. What is an application? How does CodeDeploy define an application? So I got Albert to help me out here. Any collection of content that you want to distribute to your servers in a single deployment. So that's a pretty dense definition. So let's break it down a little bit more. So an application in CodeDeploy, part of our goal is to be very flexible, and we know customers want to group their applications in many different ways. So let's take one example. An application could be a web server, so that could be a version of Apache or Nginx or kind of any low-level container that or web server that you want to serve your website on. It could be a piece of framework, so it could be Ruby on Rails or Flask or kind of that middle tier of dependencies that you might have. or an application could be the content that your actual business content, right? So this could be, your actual HTML, your JavaScript, CSS, static assets, your business-specific code. So each of these could be a separate application. You could group those into separate S3 archives or separate GitHub projects and deploy them completely independently. You can deploy them to the same set of instances or to different instances. Or you could group it all together. So we could have an application which is really all three of those in a single bucket. And CodeDeploy, as we talked about, is really kind of emphasizing flexibility. We kind of put that decision power into the user's hand to kind of figure out what's the best way for me to group and organize my application. Do I want to deploy these things independently, or do I want to deploy them as a single group? So groups, deployment groups. The other concept we talked a little bit about when we were going through the web page was this concept of a group. So now Mr. Feynman will help me out with this one. This is a much easier concept, I think, to define. A deployment group is a collection of instances you want to deploy to as a single group, as a single entity. So for our cases, we can define deployment groups in a couple different ways. A deployment group could be, excuse me, a deployment group can be defined with tagging. So either EC2 instance tagging, so tagging your EC2 instances with a common set of tags, or you can specify an autoscaling group name. So if you're an autoscaling customer, you can just tell us the name of the autoscaling group. Or you can, if you're using on-premises instances, you can also tag those. So from the CodeDeploy website, you can tag on-premises servers and flag them as for deployment. A deployment group can be a combination of any of those things. It could be one of those things or all three or any combination thereof. So you really have a lot of flexibility to kind of organize the hosts we're going to deploy to in any way you want. An application can have multiple deployment groups. So as we see in this little visualization, a very logical or a common thing we see with customers is you'll have kind of 3 or more tiers. So you can have a deployment group which represents your development environment. That could be on one version of your application. You could have a test environment or an integration QA environment. That could be a second version of your software. And then all the way in production will probably be the oldest version of your software because it's the one that's most stable, and that as you make changes, you're kind of moving them from the left to the right towards production. So each of these could be separate deployment groups. You can group them kind of any way you want. The app spec file. So I mentioned earlier that the way we actually do the way a deployment is controlled on any single instance is via this app spec file. So this is literally a piece of configuration that we would expect you to store with your application. You'll actually bundle it as part of your zip or your tar archive that you're going to store in S3, or you'll check it into GitHub along with the rest of your code. And it's really the set of instructions that we're going to carry out for you when we do a deployment. So it has 2 sections that are of interest to us. So there's a files section. The files section is really the set of commands that we're going to use to copy your content from the archive that you supply to us, so either from that S3 bucket or from your GitHub repository to the file system on the on-premises server or the EC2 instance. So this one is very simple. We're copying a config file to the web apps config directory, and then we're copying the whole source folder to the web apps my app directory. So this is a very simple example, but you can have as many of those as you want, files or folders. You can also control permissions using the app spec file. So if you want to copy a folder over and then set specific permissions, you can do that using this file format. The other section is the hook section. So this is once files are copied around, what is it that you actually want us? What is the steps that you want us to take to set up your application and get it running and available for customers? So these top-level headers that you see are what we call lifecycle events. Those are the plugin points that you can use to add your own logic. So here we have just a few of the lifecycle events. So before we install, so that's before we start copying things around. After we copy things around is the after install event. The application start event is where you might actually set up your application. So before install might be cleaning up the old application. After install might be setting up all of your dependencies. application start would then be starting up your web server or starting up your service framework or workers or whatever it is that you're running on your EC2 instances. And then finally, validate service could be any of the verification you want to do to make sure that your code is working as expected. One of the, I guess, to talk a little bit more about the app spec file, one of the things we like to see customers do and that we do a lot with our own applications is we'll check in this app spec file with our application in our version control system. The app spec file makes a nice kind of high-level roadmap of what is happening during a deployment. And more importantly, when a deployment fails, it makes a very handy place to go to figure out what's changed. So we find this very valuable in our team. Anytime a software change or a deployment fails, one of the things we will take a look at if we don't sort of immediately know what's going on is the app spec file. And we can see, by diffing two versions of the app spec, at a really quick glance, exactly what's changing. So did we change where we're moving files to on the file system? Did we add files or folders to our deployment? Did we change the scripts that we run or the order that they're run in? We can get a lot of information just from this one file that can really help us kind of troubleshoot and debug. And it means that our configuration is kind of checked in right with our code, which we also think is kind of a great best practice. So that's an app spec file. The other thing that we talked a little bit about when we did our sample deployment was deployment config. And so this is just a visualization of this rollout model that we have. So like we talked about, there's 3 canned deployment configs that you get out of the box and can start using immediately. The first is one at a time, and it's as it's described. One at a time means we'll do one host, then the next host, then the next host. If any instance fails during the deployment, we'll immediately stop. So it's kind of the most cautious possible software deployment model that you could have. It's also the slowest because we're not parallelizing any of the deployments to multiple hosts. But for production, this may be a good call for many customers. You'll also see on this page a little below each of the titles, you'll see minimum healthy hosts. This is the actual config that you'll use to specify any custom deployment configs you create. So like I mentioned earlier, you can create your own deployment configs, and the way you do that is simply by specifying this one parameter, which is minimum healthy hosts. Minimum healthy host is, as it sounds, it's the minimum number of hosts that have to be active or healthy during a deployment, right? So for this custom example, we said 75% of our hosts must be healthy. So CodeDeploy is going to use that information during the deployment to figure out 2 things. One, how aggressively it can roll out. So it actually kind of controls the parallelism. So if you say 50% at a time, we'll do half of the hosts in the first batch, and if all of them are successful, we'll do the next half. But it also helps us determine when a deployment has gone bad enough that we don't want to continue, right? So if at any point in time taking another host out of service to deploy to it would violate your minimum healthy host constraint, CodeDeploy will stop at that point. So it won't continue to try and deploy to hosts when you've kind of told it that you don't want to continue. So that's how deployment configs work. The other 2, just to kind of close it out, half at a time, as it sounds, 50% minimum healthy hosts. And then, you can always cowboy up, go crazy, and do all at once. And so that's exactly what it sounds like. This is doing a deployment to all of your hosts in parallel. Probably not a good idea for production. In testing environments, it's actually somewhat convenient. Most developers want to be able to iterate quickly, make a code change, kick it out to their integration environment, see what happens, move on. So in those environments, getting the change deployed as quickly as possible is a good trade-off to the risk of making a bad software rollout. Let's do some more deploying. So I kind of talked at a really high level about CodeDeploy. Let's actually see another software deployment. So for this example, I'll actually do a deployment from GitHub, and I'll walk you through kind of a real world, well, not a real world because I made this. Actually, I guess this is real world. This is a demo I put together for one of our AWS summits. So Ken Exner did this talk and did a live deployment using this little sample application that I put together. So I'm actually just in GitHub in my own GitHub account. This application is a Flask application that I wrote in Python. So uh, Flask is just what we call a micro framework. It's a very simple framework for creating HTTP web services or very simple websites. It's very lightweight. It runs on Python. It's pretty easy to kind of get up and get started, but I think it'll still illustrate the points of the deployment. So we have two folders here. We have the scripts folder, which I'll just jump into and show you real quick. These are just shell scripts, and you've probably written something very similar when when you're getting started with your own application. These just are scripts that I wrote to kind of automate the process of setting things up, doing a local deployment. So what we have here, setting up virtual env, setting up the web server, so this actually installs Apache or starts up Apache. And then install dependencies. I can just jump into one of these. I mean, these are really just commands to install Apache, mod, WSGI, and Python. So very kind of straightforward what's in these. But I'm going to come back to these in a moment and kind of show you that how CodeDeploy kind of makes it easy to go from your existing process to deploying on EC2 in like a more automated fashion, and how you can kind of build up on that as you go. So, to get started, I just wrote these shell scripts because I got tired of typing the same set of commands by hand on each of the instances I was fiddling around with. The other thing I'll show you real quick is the actual application code. So this application, I'll show you the actual application. I should do that too. So this is a Magic 8-Ball application. It's very simple. Essentially, every 30 seconds or so, it calls out and gets a fortune. So if I refresh, you can see I get a different fortune. Magic 8-Ball, how is the talk going? Let's see if it gives me an answer. There we go, signs point to yes. I don't know what that means. Yes, I'm going to assume it's good. So, so as you can see, it has a little bit of information here. It has a title. It's from humble instance blah. So that's the actual instance that my application is hitting to get a new fortune. And then along the bottom here, you can see the fortune gets updated. So that's the application that we wrote. Let's take just a real quick look at the code. So most of the code just lives in this single file. So you can see what we have here is a get title. That's giving us the title for the web page, and then get fortune is giving us all the potential fortunes that the Magic 8-Ball will vend out for us. So so that's basically you can imagine writing a very similar kind of getting started app for yourself. Thus far, we haven't talked at all about how CodeDeploy works here. This is just basic Flask application that you're going to run on Apache. Let's take a look at the app spec file, which really is the only additional thing we needed to add to this application to make it run. So this is my GitHub project. As I said, right at the root here, we have an appspec.yaml. That's our app spec file. And we can go through it. It should be pretty straightforward. So just like the sample app spec, we have a file section. The file section is copying our HTML and our JavaScript to the web directory of Apache. So it's just copying that folder from one place to another. Then it's taking the actual configuration that will launch the Flask container framework on top of Apache, and that's all this is doing. It's basically just copying some config files into the available sites in Apache. And then the section is our hooks, our lifecycle events. So for this lifecycle event, we're doing a couple things. One, you'll see here I have a deregister from ELB script. Deregister from ELB allows us to truly make this a no downtime deployment. So anytime we're deploying, the first thing we want to do is we want to do it incrementally so that if we accidentally push a bad change, it doesn't affect all of our servers all at once. And the second thing we really want to do if we want to deploy an update to customers and have them not notice any mistakes we might make is to redirect traffic away from the instances as we're updating them. And that's essentially what these are doing. These scripts, the deregister from ELB and the register from ELB scripts, are scripts that we wrote and vend to customers. They're available in our AWS Labs GitHub account, and any customer can kind of go pull them down and just add them right to their own application. All you need to do is add the name of the load balancer you want to use. So we're back to this. We're going to unregister our host from the load balancer. We're going to stop the running version of the application that's running on Apache. You'll also notice we can set timeouts here. So if we expect the stop scripts to take no longer than a certain amount of time, you can set these timeouts so that as you're doing the application, if a script kind of runs away or isn't returning, is doing something unexpected, CodeDeploy can kind of decide that things are off to a bad start and remediate it by moving forward, by canceling the deployment to that host or marking it as failed. Then we install our dependencies. That's the shell script that I showed you earlier. That's just installing Apache and a couple other things. We set up a virtual environment for Python. Then we start back up our web application. So we start back up Apache with the new config in place. And then finally, once that's all done, we register with the OB. So aside from the scripts that I would have written just locally to kind of get this up and running, the only other things I added here were the register and deregister commands from the load balancer, which I stole right from our GitHub account. And then this app spec file, which is really just the set of commands in the order I want to run them. So hopefully this kind of motivates the simplicity of kind of getting up and running with CodeDeploy from your existing process. You can really kind of take whatever you're doing today as far as the automation around setting up a box and kind of create a list of those events inside of an app spec, and then you can use that app spec to kind of roll it across your fleet in some predictable fashion. One of the other nice things we get with integrating with GitHub is that we can actually update this code. We can perform a deployment when we update code. So let's go ahead and show that. So as I mentioned before, we'll go back to the Magic 8-Ball application. I'll go to this initpy. One of the nice things I can do right from GitHub is just edit a file. So I'm going to make a simple edit here. We'll change the title from Hello World to something more appropriate. Hello Webinar. Is that how you spell webinar? Close enough. And then I'll just say down here, I'll give it a commit message. And then I can commit this change. So when I commit this change, GitHub, I've already done all the pre-registration with GitHub and CodeDeploy, but essentially we've registered post-commit hooks. And so now we should be able to go back to our CodeDeploy console, back to deployments, and we should see a new deployment here at the top of the list if all goes well. Yep, so 18 seconds ago, deployment started. And you can see that instances are in progress. If we go back to our application, something I didn't show you is I actually also wrote it so that you can see the load balancer state of the instances. So as this deployment is happening, you can actually see we take this instance out of service. It goes through all of those lifecycle events that we talked about earlier, and then it goes back into service. And so we can actually see, as this deployment is happening, as it's rolling across each of these three instances, we can see each of the instances go out of service, get the update, and then go back into service. So while that's happening, you'll see that this web page is refreshing. So our customers aren't seeing any downtime as a result of this deployment. We're still refreshing the page, getting new content, new fortunes, and you can actually see up here at the top where it says "Hello World." In this mix mode, it's going to jump between Hello World and Hello Webinar, depending on which server the load balancer hits. So eventually, if I scroll down, you can see the next one is out of service. In a moment, there'll be more boxes in service with the new content than there are the old content. And so then we'll kind of consistently switch to Hello Webinar. So as you can see, it's just kind of rolling through there. Let me go back here. You can actually see the deployment as it's in progress. You can get some information right from the CodeDeploy console. So you can see, at a moment's glance, you can look at this, what we call the rainbow bar, and kind of get a sense for what's happening in the deployment, which instances have already succeeded, which are in progress, or which haven't necessarily started. If a deployment fails, you'll also see instances as skipped. A skipped instance means, we couldn't honor those minimum healthy host constraints that we talked about in the deployment config, and so we stopped the deployment, and those are the instances we didn't touch. Something else that's nice about this page, is we can actually drill down to additional information. So um, we can also get a per instance view of the world. So from here, I can actually see which instances well, the deployment's over now, so they're all succeeded, but you could see the same status, which specific instances have succeeded the deployment, skipped it, haven't started it, how long those instances took to perform the deployment, their start time and end time. I can also drill down even further. I can go to events. And so now I'm actually looking at what happened on a particular instance, right? So I can actually see for each of the lifecycle events, how long it took, when it started, and its outcome, right? So these were all succeeded, so everything happened pretty quickly. Let me jump back to, so there's another example of using CodeDeploy to update an application with no downtime, kind of dynamically using GitHub. So we're kind of, you can see we're kind of tying together multiple technologies to kind of achieve a nice developer workflow. So let me go back to my slides here. Let me talk about a couple other features real quick. And I promise I'll wrap this up quickly so we have some time to answer any questions we might have. Autoscaling support, as I mentioned, you can define a deployment group using autoscaling. One of the nice additional bonuses you get if you're using autoscaling is you can also configure autoscaling to kick off a deployment as part of its lifecycle. So CodeDeploy can participate in a scale-up event, which means anytime a new instance is brought into your autoscaling group, so anytime autoscaling tries to spin up new capacity for you, that capacity won't go into service until it has successfully received a CodeDeploy deployment. So autoscaling will stand up the EC2 instance, it will instruct CodeDeploy to deploy to it. If the deployment is successful, then and only then will it add it to your load balancer and put the instance in an in-service state. So while the deployment is happening, it's not affecting your target instances, and it's making sure that when the application comes up, it actually is coming up with the correct version of software that you intended it to. If a deployment fails, autoscaling will throw away the instance and try again, and you can configure sort of how aggressively autoscaling is going to retry the deployment until it gives up. Rolling updates, this is just the name that we give to this concept of fleet orchestration. So this ability to roll out a change incrementally in pieces rather than just blasting everything to all instances at the same time. This ability, some of the other nice features of this is sort of you can go to our console or you can use our command line tools or our APIs to generate your own visualizations about what's going on. You can see directly from our status APIs which hosts are currently in progress, which have received the deployment, and kind of build up that rich set of data about what's happening when a software change is actually getting rolled out. Health tracking, this, as we mentioned, the top level CodeDeploy service is keeping track of each of the instances it's trying to update for you, and it's using that information to make a decision about what to do next, right? So if enough instances are failing the deployment, it's going to look at your constraints and decide, hey, this is going not as intended, and so let's stop the deployment, let a customer come in and remediate the problem. Also, if a deployment is going well, it's of course using that information to decide to continue. Windows and Linux support, I hadn't mentioned it to this point, but our agent is set up to run on both Windows and Linux. We have MSIs for customers, and we also have RPMs and Debian packages for some of the more popular Linux flavors. So really, if you can get Ruby to install onto your OS of choice, you can likely get our agent to run on it. Our agent is also open sourced. I didn't mention this, but if you go to AWS Labs, where we host a lot of this sample code, we have the ELB scripts. We also have the CodeDeploy agent code there, as well as some other samples to kind of help you integrate with other tools and services. Logs, log data, and deployment data. I started to go into this a little bit in the console. You saw me starting to drill down, and you could see per instance events, and you could even drill down all the way to an instance and see the lifecycle events that were happening. One of the things I didn't show is that when a lifecycle event fails, we'll actually capture some of the failure data for you. So we'll grab the last 4K of your application log, application scripts that we were running for you, and we'll make that available in the console. So we'll pipe that back through directly to the CodeDeploy console, or you can access it via our APIs. So this makes it really convenient when you're kind of first getting something set up You're maybe kind of writing your first set of app spec or in deployment scripts. You can kind of use this to kind of deploy, see exactly what happens, make a fix, redeploy, and you're getting that log data without having to log into the box and tail it or find some way to pull it off the instance. This is also very handy in the event where you're doing a production deployment and something fails. You kind of get that immediate information, which host failed, what step did they fail on, and exactly what is the error message we're seeing from the install scripts. So we try and bubble up as much information as we can to you so that you can kind of take an action. I mentioned this one a lot, so I won't dwell on it. On-premises deployments, you can install our agent not just on EC2 instances, but you can also install them on your own servers in your data centers and use us in both places. Product integrations. Before I close out, I just want to make a call out. As I said way at the beginning of this talk, we really wanted CodeDeploy to be a flexible deployment system. We wanted it to be a building block that you could integrate with a lot of your existing processes. So we spent a fair amount of time before we launched working with partners and building our own integrations to try and make it easy to kind of plug CodeDeploy into your own process. So I demoed GitHub earlier. We work with a couple other continuous integration services like Travis, CircleCI, CodeShip. We have a Jenkins plugin that's available in the Jenkins plugin repository, but also available on AWS Labs. So if you use Jenkins as part of your continuous deployment or continuous integration process, you can actually kick off a deployment directly from the Jenkins framework. Chef and Puppet, Ansible, and other configuration management services. We've seen some of our early adopters have used CodeDeploy with these other configuration management systems. They really like the ability to kick off a Chef run on an instance, but then use CodeDeploy for that kind of higher level fleet orchestration. And so we find that these kind of play very well together. Essentially, your app spec file will end up being, just an instantiation of your Chef cookbooks or your Puppet runbooks. And I think we also have some examples of that in the Jenkins repository as well. So I'm sorry, not Jenkins, the GitHub AWS Labs repository. So head over there and check out what we've got. Okay, so I'm a little bit over time.